Good afternoon, everyone. Thank you for joining us today. How are you all doing today? I hope you've been having a good week so far. I see I have a question already, so I'll be able to help you with that, Esther. Thanks for joining the session today. I'm looking forward to the hour with you guys and guys and gals. Please, if you have any questions during the session, feel free to send them across. I have some questions from some students already, so I'm going to address those. Esther, your question would also be addressed today. So I'll give a few more minutes for everyone to just trickle in and to join the session, and then we will get started. How are you all doing with school so far with the distance learning? Are you guys finding it easy? Is it challenging? Are you getting used to it? Let's just have a little dialogue before everyone trickles in and we have a session. So how's everyone doing with the online session and your online school? Is anyone finding it difficult? Anyone finding it easy? Is it an adjustment for you all? Let's go ahead and chat a little bit. I hope you're telling your friends about this session that we have. Go ahead and, if you have not, share with your friends. I'm sure some of you feel like your questions are getting answered. I'm sure there are other students in your school that are struggling with the same things you struggle with. Share this link with them. Help get them to subscribe so that when we have sessions coming up, they can also get the notification and the alerts as well. Okay, so today's session will be mostly 8th to 12th graders. Today's session will be mostly 8th to 12th graders, so we're going to start with questions for 8th graders. I have some Algebra 1, some geometry. I also have some Algebra 2 type questions. And whatever questions you send during the session, I will address them today. And of course, at the end, we're going to have two puzzles that we'll use to end the session. So thank you, Ini, for your contribution. Looks like you've already solved the question. So let's go ahead and see if there are any other 8th graders that want to try this out, and then we'll go ahead and start. All right, let's give a few more seconds for everyone to try this out, and then we'll do it together. All right, let's go ahead and do this together. So we want to look at math. Math needs to score an average of 90, an average score of 90 to pass his 8th grade achievement class. His scores on the first first four tests are 97, 89, 91, and 82. What must he score on the 5th test to pass the achievement class? So we need to first start by looking at what average is. What is the average? Your average is the sum of all the numbers, divided by the count of numbers. So here we already know what our count is. Our count is 5 because there are going to be 5 tests. Okay, because we're looking for the score on the 5th test. So we have 5 tests. So we're going to find out what must the score on the 5th test be if we have to have an average of 90. So let's go ahead and do this. We have 90 for our average. So the scores we have so far are 97, we have 89, we have 91, and we have 82. I'm going to use X for the 5th test score. So we want to find out what must X be for for math to pass this class. So what we're going to do now is we're going to multiply 90 by 5 because we need to know the sum of all these numbers. So we have 90 multiplied by 5 is 450. It's going to give you 97 plus 89 plus 91 plus 82 plus x. So let's go ahead and add all these numbers together first. So we have 97 plus 89. Let's go ahead and add this. 7 plus 9, 16. 6, bring one up here. 10 plus 8, we have 18. Let's go ahead and add 91 to this. 6 plus 1, 7. 8 plus 9, 17. We write 7, bring one up here. So this is 277. And then we have 82. So now we have 7 plus 2, 9. 7 plus 8, we have 15. We write 5. Bring one up here. 2 plus 1, we have 3. So now we have 450 is equal to 359 plus x. So now we're going to subtract 359 from both sides to get the value of x. And remember, x is the score on the fifth test. So we have 450 minus 359. So this is going to give us 4 here. This is 10. 10 minus 9, 1. We're going to take 1 from here. 3. This is 14. 14 minus 5, we have 9. So Matt needs to score a 91 on his fifth test. So 91 on fifth test. Good job, Ini. So he needs to score 91 on the fifth test. Are there any questions about the approach to this? Any questions about this type? Any questions? Do you have anything you want me to go over again? I don't have a problem doing that. And so let's go ahead. If there are no questions on this, we will go ahead to the next question here. What I'm going to do for the next question, because Esther has a question, I'm going to address her question next, and then we'll go ahead and we'll go ahead with the other questions. I do have some questions from other students as well. So let's go ahead and deal with Esther's question. So we have 81x squared plus 180x plus 100. So we want to find out how to factor this completely. All right, so I would use the ax squared plus bx plus c equal to 0. Well, this is an expression, so we don't need to equate it to 0. So here, a is equal to 81, b is equal to 180, and c equal to 100. So now we're going to find out the factors of AC. So factors of AC that give us B. So factors of AC that add up to B. So AC is 81 multiplied by 100. 81 multiplied by 100. And we're going to have 8,100. But as you get, this is most likely an algebra 2 style question, but here is something that I want you to be able to also do. There's something called a discriminant. And discriminant is b squared minus 4ac. So you can use this actually to tell you if you're going to have an easy experience factoring this. So let's go ahead and find what b squared minus 4ac is going to be. So b squared is 180 squared minus 4. This is 81. And then we have 100. So this is going to give us 32,400. 81 multiplied by 100 is 8,100 multiplied by 4 is going to be 32,400. So this tells me that this here is going to give me 0. All this tells me is that I'm going to have a perfect, is going to be a perfect square. Because when you have b squared minus 4ac equal to 0, you have a perfect square. So now that gives me enough information. Now that I have a perfect square, I can actually abandon this approach. Now that I have a perfect square, what I'm going to do is I'm going to find out the square root of 81x squared and the square root of 100. So now what that's going to give me, the square root of 81x squared is 9x, the square root of 100 is 10. So this right here, because I had b squared minus 4ac equal to 0, all I can do here is I can say 9x plus 10 squared. Now let's see, there's another way we can prove that. So let's look at 8100. So we have 8100. We want to find out the factors of 8100 that add up to 180. So we can have 8100. This is going to take a long time, but I can easily say 90 here and 90 here because the square root of 8100 is 90. So I have 81. Let me erase this. If you need some more explanations, let me know. So I have 81x squared plus 90x plus 90x plus 100, and then I can actually factor by grouping right here. So let's look at the common factor here is 9x. We have 9x plus 10, and then a common factor here is going to be 10. We have 9x plus 10. So now our greatest common factor here is 9x plus 10, and our other factor combined will be 9x plus 10, which is equal to 9x plus 10 squared. So these are two different ways you can get to the same destination. What I always like to do, especially, you probably won't get introduced to this approach until you get to about algebra 2, because this type of a question will be given in like algebra 2 and above. This could actually also be a college type question. So what you want to do here is you use b squared minus 4ac to just give you a guide on what you should do. If it tells you that your b squared minus 4ac equal to 0, all that tells you is that you have a perfect square, and then you can use this approach to go ahead and factor it. So this is going to give you 9x plus 10 squared. I hope this helps. Esther, did this help you? Okay, fantastic. All right, let's go to our next question here. Algebra 1, Algebra 2 students, we're going to look at composing. You're welcome. Thanks for asking the question. I'm sure it's helping somebody else. So we're looking at Algebra 1 and Algebra 2 question here. We want to compose the functions here. F of x is equal to 1 over 4x plus 1. G of x equal to 9x minus 3. And h of x equal to 2 over x. What is the value of g of h of f of x? What is the value of g of h of f of x? Of f of negative 1/2. So the hint here is you want to first find out f of negative 1/2. Then when you get that value, you want to find h of that value. When you get the value for h, you get g of that value. So that's really what we're going to do for this type of question. This is very common in Algebra 2, and some Algebra 1 teachers may teach it toward the end of the semester, but this is a very common Algebra 2 question. So I'll show you how to go about this, just so that we can, so if you're not aware, you can at least get a head start on this. So f of x is 1 over 4x plus 1. So let's go ahead and look for f of negative 1/2. So it's going to be 1 over 4 multiplied by negative 1/2 plus 1. So this is going to give you 1 over, what is 4 multiplied by negative 1/2 is negative 2 plus 1. So this is going to give us 1 over negative, my bad. So it's going to give you 1 over negative 1, which is negative 1. So now we're going to find h of negative 1. So this is going to be h of x is 2 divided by negative 1, which is going to be negative 2. And now we have g of negative 2, which is going to give us 9 multiplied by negative 2 minus 3. So this is going to give us negative 18 minus 3. And when we are dealing with negative numbers, when we have the same signs, we're just going to keep the sign and then add the numbers together, 21. So this is going to give you negative 21. So therefore, we can say g of h of f of negative 1/2 is equal to negative 21. So that is that. All right, let's look at the next one. I believe it should be a geometry question. All right, so we're looking for the area of a hexagon. A hexagon is a 6-sided polygon, and this is what we call a regular hexagon. We want to find the area of this polygon. There is a formula for it. So let me know if you have any questions as we proceed. There's a formula for this type of question, but I think it's difficult to memorize formulas and find yourself effective at dealing with different type of questions. So this is going to test a few things that we know. We know about our perimeter. We know also about we're going to use some trig ratios here. And so what I'm going to do here is we're going to locate the center of this polygon, which is right here. Let's put it right here. My bad. So right here. So what I'm going to do, I'm going to come up with 6 different triangles, because let's say one right here. We got this triangle here. We have another triangle here. We have another one here, and then one here. So let's count our triangles. We have 1, 2, 3, 4, 5, 6. We have 6 different triangles. And what we can see here is, because this is a regular hexagon, the area of all of these triangles are going to be exactly the same. So we're going to do we're going to find the area. We're going to find the area of the first triangle. Let's pick one triangle. So let's take this one here. The base is 8 centimeters. And then we are going to go ahead and try to find, what do you need for area of a triangle? Area of triangle is going to be 1/2 base multiplied by height. So here we don't have a height yet. We don't have a value for the height. We have the base. And so we're going to find the height. So now when we split this into this altitude here, is going to divide this into 2 equal parts. So we have 4 here and then we have 4 here. And we need to find, what about the angle in the center? Remember, you have it's almost like a circle right in the center. So you have a circular center. And so you have 6, 1, 2, 3, 4, 5, 6. So you have 6 different angles here. And so each of those angles is going to be 60 degrees. And so I'm going to do something here. I'm going to bring out this triangle. I think it'll make more sense that way. Let's bring out one of the triangles, because I'm going to draw a right triangle. I'm going to make a right triangle out of this. Give me a second. I'm going to make a right triangle out of this. And actually, let me just draw it myself. So I'm just going to make my right triangle. It's going to look like this. Okay. So I need to find this. This is the height. I have this from from this point here to this point is going to be 4 units. This is 60, and I'm dividing this by 2, so this is going to give me 30 degrees. Okay, so now we need to find out the value of the height. What is the value of the height? We have tan of 30 is going to give us opposite, which is, don't forget this, SOHCAHTOA. So we have the opposite side to this angle and we have the adjacent. So tan is our best option. So it's going to be 4 divided by h. So we need to find the height of this triangle. So if you're familiar with your angles, you know that sine 30 is 1/2. Cosine 30 is √3/2. And then we have tan is equal to sine divided by cosine. So this is going to give you 1/2 divided by √3/2, which is 1/2 multiplied by 2/√3. So this is going to give you, we cross this out, this is 1/√3, and then we multiply numerator and denominator by √3, is going to give us √3/3. So therefore, your tan right here is √3/3. This is an intermediate algebra question, very common in intermediate geometry question. It's very common in the geometry classes for AP students or pre-AP students. So this is going to give you √3/3 is equal to 4/h. So we're going to cross product this, and we have √3h equal to 12. So we're going to divide this by √3, both sides by √3. So your height is 12 divided by √3. You can go ahead and multiply by √3/3, which is 12 square root of 3/3, which is going to be 4 square root of 3. So now our height is 4 square root of 3. So now let's go ahead. This is going to be, let me write this in a different color. This is 4 square root of 3. So now let's go ahead and find the area of that triangle. The area of that triangle is going to be, 1/2, what's your base? The base of the whole triangle is 8. And then your height is 4 square root of 3. So let's go ahead and divide. So now we have the area of the triangle is 16 square root of 3. Now what we're going to do is, because this is the area for one of these triangles, it's going to be the same area for all of the other 5 triangles. So therefore, the area of the hexagon is going to be 16 square root of 3 multiplied by 6, which is going to be 96 square root of 3. This is a very common question for, don't forget, for those who are in geometry, especially pre-AP geometry, you'll see things like this, and this is going to be square centimeters. Any questions on this? Any part of it that you don't understand, that you want me to repeat? It's going to be close to about 192, but it's not exactly 192, because 192 is 96 multiplied by 2. This is going to be a little bit less. So it's going to be about, let's see, it's about 96 multiplied by 1.7. So it's in that range, probably closer to 170 than 190. All right, any questions on this? If you're learning this already, let me know if you have any questions, or if you've not learned it, let me know if you have any questions. And if there's, because there are different aspects of math that I've brought in here. There's, you'll see here rationalizing radicals, you see trigonometric ratios and all of that stuff. So there are a lot of different things that factor in here, and this is an approach that you can use for any type of polygon. You can use it for pentagons, hexagons, and so on and so forth. All right, so let's go ahead. Since there are no questions on this, let's go ahead and try the next one. This is for 8th graders. Find the volume of the cylinders for what I'm doing here, you can leave your answers as pi. Leave your answers as pi. Answers with pi. Let's go ahead. You can leave your answers with pi. What is the volume of the cylinder below? What is the volume of the cylinder below? Remember, volume is area of base multiplied by height. So area of base multiplied by height, so you have to do some work to find the area of your base here, and then you multiply by the height. Oh, Moffat, thank you. Thank you for your contribution. That looks good. So volume is, the first thing you need to know here is what is your base? Your base is you have a circular base right here. You have a circular base right here. So you're going to use volume equal to pi r squared, which is the area of a circle, multiplied by your height. Okay, good job. So this is pi. R is 14. We square this and we multiply by the height, which is 28. So this is going to give us pi multiplied by 196 multiplied by 28. Let's go ahead and find the value of 196 multiplied by 28. 196 multiplied by 28. 6 multiplied by 8, we have 48. Write 8 here, bring 4 up here. 9 multiplied by 8, 72 plus 4, 76. We write 7 here. 1 multiplied by 8, 8 plus 7, we have 15. I'm going to put a 0 here. 6 multiplied by 2, we have 12. Write 2, bring 1 up here. 9 multiplied by 2, 18 plus 1, we have 19. So 9, bring 1 up here. 1 multiplied by 2, 2 plus 1, we have 3. So this is going to give you 8. We add them up. 8, 8, 4, 14. So we bring 1 up here. So this is going to give you 5. So this is 5488 pi cubic feet, because it's a volume. It's a cubic feet. All right. Any questions on this? All right, if there are no questions, let's go ahead to the next one. Algebra 2 question here again. So we have 25x squared minus 49 equal to 0. This is actually Algebra 1, but it starts in Algebra 1, but you also cover it again in Algebra 2. 25x squared minus 49 is equal to 0. What I'm testing here is the difference of two squares. When you have the difference of two squares, I'm going to help you out with the formula here. The difference of two squares is that when I have a squared minus b squared, I'm going to have this written as a plus b multiplied by a minus b. So when you have two squares, a squared minus b squared, we're going to rewrite that as a plus b multiplied by a minus b. A plus b multiplied by a minus b. So now the task you have at hand is to find out what a is and what b is. What is a going to be? What is b going to be here? 25x squared minus 49 equal to 0. So there are two different ways we can do it, and I'm going to show you the two different ways. And I always want you to feel like you have your own approach that you can work on and be consistent with. So 25x squared minus 49 equal to 0. All right, let's take the first approach. The first approach. Oh, marvelous. Thank you for joining. You're close, actually. You're very close. But look at the square root of 49 again, and that would give you your hint. So what we have here is 25x squared minus 49 equal to 0. So we need to find out, is 25x squared a perfect square? If it is, what is the square root? Is 49 a perfect square? If it is, what is the square root? So here's what I like to do. 25x squared minus square root of 49. So the square root of 25x squared is going to be 5x, and here I'm going to have 7. So our A is equal to 5x and our B equal to 7. So now what we're going to do is 25x squared minus 49 equal to 0 is going to be written as, remember we say A plus B, so 5x plus 7, and then we have A minus B, we have 5x minus 7, this is equal to 0. So now we know that, great. So we know that for two numbers, when they are multiplied together to give you a product of 0, any one of them could be 0. So 5x plus 7 equal to 0. Let's subtract 7 from both sides. So 5x equal to negative 7. We're going to divide both by 5, and we have x equal to negative 7 over 5. And then we also have 5x minus 7 equal to 0. We're going to add 7 to both sides. So 5x equal to 7. We divide both sides by 5. And we have x equal to 7 over 5. So here, now we have x equal to 7 over 5, or negative 7 over 5. Now there's a second approach that is not quadratic formula based, or is not quadratic equation based. What we're going to do here is we're going to say 25x squared minus 49 equal to 0. I'm going to add 49 to both sides. Some people learn it this way, so it's fine to use it if you know how to use it. 25x squared is equal to 49. So now, because we have x squared here and we need to find the value of x, we're going to find the square root of both sides. But here's something you have to pay attention to. So we have 5x. When you're trying to find the square root, you have to account for positive or negative on the right hand side. 5x is equal to positive or negative 7. So you have two choices. 5x equal to positive 7. You divide both sides by 5. And then you have x equal to 7 over 5. And then you have 5x also equal to negative 7. And then you divide both sides by 5. And then you have x equal to negative 7 over 5. The reason why this method is the preferred method is because sometimes you don't remember that this needs to happen. You don't remember to put the positive and the negative for the square root of the number on the right. That is why this method is preferred, because you're actually forced to use it when you factor. Any questions? Any questions? If there are no questions, we'll go ahead to the next question. I believe, yeah, this is a question that was sent, a type of question that was sent to me. So we're going to go ahead and we're trying to find the value of x. So we have a right triangle. We have two of the sides of the triangle, and we need to find the angle for that. We need to find one of the angles for the triangle. So every time you see a right triangle, it's always safe to do this. So, ka, toa. It's always safe to do this. This is sine equal to, yes, suka toa is involved. Opposite over hypotenuse. So I'm going to give you a few seconds to try this out. And then cosine is adjacent over hypotenuse, and tangent is opposite divided by adjacent. So let's give you a few seconds to try it. I want to see a few responses on what is going to be the value of x. X is an angle. what is going to be the value of x that makes this a right triangle. Note that you can use a calculator for this one. Actually, you will need to use a calculator for this one. I'm going to show you how to, once we get to the point where we need to use a calculator, I will show you. Okay, yeah, so far so good. More fair, that's good. All right, I'm going to use the calculator, but not right now. I'll let you know when to use it. Okay, so we're at the point where cosine, okay. That's fine. You're doing good though. You're doing good. All right, so let's go ahead and since we're making some good progress with the responses here, let me show you what to do after that point. So now we look at this angle here. Let's look at the different sides. This is opposite right here. This is adjacent, and this is hypotenuse. So if you look at this ratio here, we have the adjacent, we have the hypotenuse, and then we're looking for the value of x. So adjacent hypotenuse, so that's cosine. So cosine of x is equal to adjacent, which is 28, hypotenuse, which is 40. So we're going to simplify this. Go ahead and divide by 4. So we have cosine x is equal to 7/10. And if you can, well, you can either convert this to a decimal if you want, or you can leave it this way. So now let's bring out our calculator and see how to use the calculator for this. So some calculators will allow you, I think most graphing calculators would allow you to just use cosine. Let's see, it's going to be, second function here is going to be the inverse of the cosine right here. That's the function you're going to use. So it's not going to be 90. And this calculator here requires me to first figure out what 7/10 is. So let's go ahead and do that. We have 28 divided by 40 here. That's 0.7. Now we can use the second function right here for cosine. And so that is going to be 45.57. So some calculators will allow you just do this. Most graphing calculators, especially the TI, I think anywhere from TI 83, you can actually just do this. You can just do cosine of 0.7, or you can do cosine inverse of 28 divided by 40. So this is going to give you x is equal to the inverse cosine of 7/10, which is going to give you about 45.57 degrees, or we can just make this 45.6 degrees. So does this help? This is how you would do a problem like this when you have two sides of a triangle, of a right triangle especially, and you have a missing angle. This is the approach you will take. Does this help? Is there any part of it that is not clear? So we can take a look at it again. If there's, okay, good. So Mofe, do you understand what to do next? Okay, you got it, the inverse. All right. Okay, so now we have a sector. We want to find the area of this sector. Oh, you're very welcome. You're very welcome. We want to find the area of the sector, and you can leave your answer in terms of pi. You can leave pi in your answer. That's good, Jaden. Thank you for participating. You were quite close. So we want to find the area of a sector. What is the area of a sector? Always think of a sector as a slice of pizza. That's the easiest way to remember it. A sector is a slice of pizza. And the reason why we say it's slice of pizza is because I want you guys to think of the word area, because a slice of pizza is you can act, it's not around it, it's not around the boundaries of the object, it's inside the object. The pizza, it's so your slice of pizza, you have the component of the pizza itself inside the circular object. So that's what you want to always remember when you're dealing with area of a sector. So the best way I like to think of area of a sector is a fractional area of the circle. So this is area of a sector is going to be, so this full circumference, we're looking at area. So we need to look at, I think you're referring to the angle in the circle. The full angle in the circle is going to be 360. So area of a sector, I'm going to look at this as a fractional area of a circle. So what we're going to do first is we're going to find the area of the circle, and we're going to leave pi in our answers. I don't really care about the value of pi in most of these questions. I want you to understand the concept behind it and not just having to put stuff in a calculator. So the area of a circle is equal to pi r squared, which is going to be, and our radius here is 24, so this is pi multiplied by 24 squared, which is 576 pi. So what I want you to remember here is 576 pi represents your whole circle, and your whole circle is 360 degrees. But here our sector here is only 75 degrees. So the fractional area of that sector is going to be 75 divided by 360, because we want to find out the fraction of the circle, and we multiply by the area of the circle. That's going to give us the area of the sector. So let's see what we can do here. We can divide by 3 here, and we have 25, and then here we have 120. We can also divide by 5. We have 5, and then we have 24, and then we now have 576 pi divided by 24. This is going to give us, let's see, what are we going to divide by? Divide by 2 here, divide by 2 here, because they're even numbers. We have 288 pi divided by 12, and then we can go ahead and do that. 288 divided by 12. How many groups of 12 in 28? We have 2. 2 multiplied by 12, we have 24. We subtract, we have 4, bring down 8. 48 divided by 12, we have 4. 4 multiplied by 12, we have 48. So 0. So this is going to be 24 pi square inches. So you can see here that the area, oh, that's incomplete, because we have to multiply that by 5. So my bad on that one. This is why I like to write all the questions. I like to write all my steps so that I can know when I'm wrong. So here I have 5 multiplied by 576 pi divided by 24. So we're going to have 5 multiplied by 24 pi, which is 120 pi. So pay attention to detail here. So that's all we do here. So we find 5 multiplied by 24 pi, it's 120 pi. So this is going to be the fractional area of this circle. Any questions on this? Any questions? This is geometry again. Area of sectors. This actually, I have seen this show up also in pre-calculus, so just take note that it's something that follows you quite a bit. When you get to pre-calculus, you do quite a bit of this type of questions, but geometry allows an introduction to the concept. All right, so let's go ahead. We're going to be rationalizing radicals. We are going to rationalize radicals here. Let me go ahead and draw my square here. So let's see. then so that's one of them. So we're going to so square root of 2 minus 3 over square root of 3 minus 4. What we want to do here is, just as a best practice in math, we don't like to have irrational numbers in our denominator. We don't also like to have negative numbers in our denominator if we can avoid it. So what we're going to do here is, we need to find some number or term to multiply the numerator and the denominator of these fractions so that we can get rid of the irrational numbers from our denominator. So what we're going to do here is we're going to find the conjugate. The conjugate is that expression that we can multiply our denominator by to get rid of the radical. So another thing, that this is where your a squared minus b squared equal to a plus b multiplied by a minus b also comes to play. So we want to find out a squared minus b squared. So what do because if I square this, I get rid of the radical. So I'm going to multiply it by square root of 3 plus 4. So you can see here, because I'm going to end up with a squared minus b squared, you can see that I have a plus b, which is this right here, and a minus b. And then I'm also going to multiply the numerator by square root of 3 plus 4. Now you may ask, why are we doing this? The reason why we do this is because if you divide square root of 3 plus 4 by square root of 3 plus 4, what do you have? You have 1. So therefore, you're actually multiplying this whole fraction by 1. So that means the fraction doesn't change at all. So now we're going to multiply square root of 2 minus 3 by square root of 3 and plus 4. So let's go ahead and multiply across. So this is going to give us square root of 6. This is going to give us negative 3 square root of 3. This is going to give us 4 square root of 2. And this is going to give us negative 12. So now we have square root of 6. We're going to take everything from inside of the squares. Square root of 6 minus 3 square root of 3 plus 4 square root of 2 minus 12 divided by, what is square root of 3 squared is square root of 9 minus 4 squared is 16. So this is going to give us, do we have any common terms here? No, we don't. We don't have any common terms here. So we're going to go ahead and have square root of 6 minus 3 square root of 3 plus 4 square root of 2 minus 12 divided by 9 minus 6. This is square root of 9 is 3. So that's 3 minus 16. So we're going to now have it as square root of 6 minus 3 square root of 3 plus 4 square root of 2 minus 12 divided by negative 13. Now what I like to do is, as a best practice, I don't like to have negative numbers in the denominator. So I'm going to multiply the numerator and the denominator by negative 1. We're going to multiply both of them by negative 1. So what we're going to have here is now negative square root of 6 plus 3 square root of 3 minus 4 square root of 2 plus 12 divided by 13. So this is another way of writing this radical. Okay, so now we have our puzzles for the day. We have 2 puzzles for the day. Are there any questions on everything we've talked about so far? If you have any questions or any topics that you want us to work on, we can do that tomorrow as well. We have about 10 minutes to go. We can do that tomorrow, because tomorrow we will have all our groups from elementary all the way to high school. And so I want to know, let's look at that. Could we combine the terms? Let's see. So if we look here, you have the square root of 3, you have square root of 6, we have square root of 2, and then we have 12. So there's nothing that is common. If I had something like negative 4 square root of 3 minus 3 square root of 3, now I have some common terms that I can combine. But because these terms are so uncommon, they are so dissimilar, they don't look alike, so we can't combine them. We can only combine terms together if they look alike. Thank you for the question. That's a really good question. So the answer to that is no, we could not combine just because they don't look alike. Any other questions? Okay. All right. All right, so we're looking for the missing number in the puzzle below. What is going to be the missing number here? So we have 108, we have 84. Okay, okay. Good try, good try. Okay, let's go ahead and try this out. 84, okay. So Jaden, Esther, and Ini, thank you. Thank you for your contribution. Thanks for trying this out. All right, so how are we going to go about this? We have two choices, actually. There are lots of different ways to get here. We can actually add these numbers together. 74, Ayo. Okay, 84, all right. So we can add these numbers together. We'll give you 12 and then multiply by 3, you get 36. We can also add these numbers together. You get 20, you multiply by 3, you're going to get 60. And then we can multiply this together. We have 28 multiplied by 3, we have 84. So that's one approach. The other approach is to go ahead and just multiply this number by 4, which gives you 36. Multiply this by 4, gives you 60. Multiply this by 4, gives you 84. So either way, you get to 84. Now let's look at our final puzzle for the day. This one is going to make you think a bit. Okay, anyone want to try this? This is actually quite interesting. All right, anyone want to try? Let's see if we can give you some more time. 45, okay. Let's see what this one should be. Anybody else want to try? Okay, let me show you some hints here. So take note that this is half a cup right here. This is a full cup. This is a full cup. So we have 2.5 cups equal to 15. So let's go ahead and divide 15 by 2.5, which is 15 divided by 5 over 2, which is going to give us 15 multiplied by 2 over 5, which is 6. So each of these cups is 6, 6, 3. So this cup here is 6. Now we have a full cup minus half a cup. So we have 1 cup minus half a cup. So that is going to give you 4. So 1 cup minus half a cup is half a cup. Half a cup is equal to 4. So a full cup is equal to 8. So this is going to be 8 minus 4 plus 6. And then here we have 1 cup plus 1 cup minus half a cup. So 1.5. Okay, Anna, good try. 1 minus half a cup is 2 minus half a cup is 1.5 cups equal to 6. So we're going to divide, let's call these R. So we're going to divide this by 1.5. 6 divided by 1.5 is going to be 6 divided by 3 over 2, which is 6 times 2 over 3, which gives you 4. So now this is going to give you, this is going to give you 4. This is 4 right here. This is 4. This is 2. All right. So in our final row, we have half of a blue cup, which is going to give you 3. We have half of a blue cup and half of a red cup. A red cup is 2, and then half of a blue cup is 3. We add that. That's going to give you 5. And half a yellow cup is 4. So what we have here is, that's all you have to do. Half of a yellow cup is 4. So we have 3 plus 5 multiplied by 4. 5 multiplied by 4 is, don't forget, whenever you're dealing with operations, PEMDAS. PEMDAS, PEMDAS, PEMDAS. And when you have your PEMDAS, your multiplication and division comes before your addition or subtraction. So you're going to have this. It's going to give you 3 plus 20, which is 23. And that is your answer, 23. Never forget, whenever you see a bunch of operations mixed together in a sentence, in a mathematical sentence, or in an equation, always respect PEMDAS is the order in which all your mathematical work needs to be done. So this is 23. And are there any questions for me? We'll have another session tomorrow. And don't forget, tomorrow's session has the elementary school students all the way through 7th grade. So we're going to try to accommodate as many topics as possible. But if you have a question or a topic that you want us to go over tomorrow, or if there's a topic that was covered today that just hasn't really made enough sense for you and you want us to address them again tomorrow, I'll be glad to do that. I'll give priority to that. So do let me know if you have any questions, and then we'll be glad to walk through that. I hope this session has been helpful to you. And so thank you for your time. Thank you for the hour. I know you have some other maybe homework and all of that to do, and you have given me 1 hour of your time. So I really appreciate it. And I look forward to our session again tomorrow. And please stay safe. Keep yourself safe and your family safe as well. And I will look forward to the time with you tomorrow. Be blessed and have a good rest of your day. Thank you. And bye for now. Also, go ahead and if you have not subscribed to the Math Is channel, Math Is Tutors channel, please go ahead and subscribe. Share with your friends. This video is going to be made available in about 20 or 30 minutes to the public, and so you can share them with your friends as well. And let's get this going. Thank you so much. Be blessed.